Hey everybody, today just going over new information that I recently developed about the GPT prompting, and some of the more state-of-the-art approaches to do that. The most recent innovation is in the PAL program-aided language models. It's a very interesting approach to inputting and creating prompts into large language models and OpenAI in particular, uh, simply because that's what we're using here. But this works for, I would imagine, all language models, large language models. And the idea behind program aided language models is to be able to basically put in code within your prompt, within your request to the AI. The way that it differentiates from some of the previous methods is that there was direct prompting, where you basically ask something quite specific, give me three, what is 3 plus 3? Then there is the chain of thought prompting, which is a lot more effective than direct prompting. And chain of thought prompting is laying out the instructions, some examples, any kind of specificities, and then asking the bot to basically reflect on itself and ask any questions if necessary. So chain of thought provided a significantly better rate of return and significantly improved results when prompting in chain of thought as opposed to direct prompting. Well, this is the latest iteration of improving results from large language models, and that's using, again, the program-aided language. And program-aided language is fairly self-explanatory overall. Within the actual prompt request itself, we put in some code which allows the large language model interpreter to understand the code. So it's, as it goes down, because it's capable of understanding code and writing in code, it then takes in the instructions that are given in code and has a much clearer understanding of what to do, because it's using its kind of embedded code interpreter. In this case, in all of these examples, is going to be Python. But the language model in its input and output is able to understand code, so it's also able to input the code and as an instruction and understand much better each step of the way than even chain of thought. So that is what these very smart people over here discovered recently through some of their tests. And these are the results, and we'll go over that right here, and I'll show you the examples besides this one. So overall, the abstract is the program-aided language model is a new method that uses large language models to read natural language problems and generate programs as the intermediate reasoning steps. But it offloads, and it's important, it offloads the solution step to a programmatic runtime such as Python interpreter. So with PAL, decomposing the natural language problem into runnable steps remains the only learning task for the LLM, while solving is delegated to the interpreter. So the natural language is basically the way that the LLM is going to handle most of it. But when it comes to certain problem solving, which it's had issues with and still has issues with, especially when it comes to arithmetic, and oddly enough, sometimes even to simple arithmetic. But word problems and simple arithmetic, the LLM has a lot of issues with. And even in chain of thought approach to prompting, it also has some odd results, as I'll show you shortly. So the difference is we have chain of thought, which up to now was the kind of the standard, the state-of-the-art standard approach to prompting. So you have a input. Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? You would then give an example. So this is the way you offer a question that resonates to the actual question that you will be asking later on. You provide an example answer as to how to achieve this answer. We got 2 cans of 3 tennis balls, which is 6, plus you started with the 5, the answer is 11. And then you ask it the question that you want to know, which is, so bakery baked 200 loaves of bread. On Monday, they sold 93 loaves and 39 loaves in the afternoon. So they sold 93 in the morning and 39 in the afternoon. And then the grocery store returned 6 unsold loaves. How many loaves of bread do they have? So with this chain of thought, example, question, answer, example, and then the actual question, the model, and so several models that they tested this with, especially the ones that they did it was on DaVinci. And I don't think they did this with GPT 3.5, but as I'll show you in a little bit, GPT 3.5 still has issues. However, 4 seems to have done significantly better. So their results are not with GPT 4. So as you can see here in this one, it gets it wrong. It gets the answer 62 because it still thinks that the 6 unsold loaves that were returned, for some reason it thinks that they were part of the sold equation as opposed to having this be a plus 6. It continues to think it's negative. So when this same exact approach is then rewritten in a program aided method, we have the question, we have then an example given in a code-like format that uses just some basics Python coding syntax, and the same exact question then afterwards. And so the model then starts to reason and sends out the calls for actual kind of arithmetic programming tasks. You can see in the red, it sends that out to the interpreter. And because it does that, because it uses only the language element, the natural language in the blue, and then the mathematical part, the arithmetic in the red, in combination, it actually gets the correct answer. And so according to their research, this correct answer happens a whole lot more than it does with either direct or chain of thought when it comes to picking out colored objects, penguins in the table, and data understanding. These are 3 different tasks that they were given, and it outperforms chain of thought on 12 benchmarks. And that's a fairly important outperformance here, 86 to 95, 79 to 93. These are big leaps, big jumps. These are the different kind of mathematical reasonings, and I think this is kind of general math, general mathematics hard, some kind of this is multiplication, division tasks, some kind of single equation, single operation, add, subtract, and then multi-arithmetic. So in all cases, it has significant improvement. Well, most cases, I guess. Here is like not that much from chain of thought with this particular instance. I'm not sure what this is. This is using a language model that is a very large one, Palm 540 billion parameters. So that's a very large one. And compared to that one, the program-aided reasoning wasn't all that different in certain tasks. But overall, you can see improvement across the board. And in certain cases, very, very significant, like algorithmic reasoning. So even chain of thought had a huge fail. So these are going to be very important things to consider when we're doing chains of prompts. And especially now more and more applications are using recursive prompting with some consideration like indefinite memory, where one prompt is going to be used as an input to the next and to the next and to the next, or you'll have multiple agents, multiple GPT agents working in unison and generating different prompts together, and one feeding one output of one prompt going in as the input of the other. So when you're doing these prompts in direct or chain of thought, you're going to have a whole lot of problems down the line. So you're going to have a huge explosion kind of chaos further down the tree when your first prompt is already returning results that, as you see, like chain of thought, 25% of the time, it could come back as just some gobbledygook. And that 25% of the time is going to get, that trash is going to get fed into your additional prompts and so on and so on. And so you're going to run something that, could be for a good long while, use up a whole lot of tokens, and then come up with just nothing but trash. But the program-aided language approach has a really, really good result. So as you can see in some of the examples here, you should check this out, reasonwithpal.com. You can see that there are sample outputs here, and you can see that when you select certain outputs, it gives you what the question was, what the actual chain of thought prompt would be, and then what is the program-aided language prompt. So very cool. You can select these and copy paste and play around. You can see that certain questions, like there's date questions, and chain of thought is coming up with one answer, and then language model is coming up with the correct and accurate one. So you can try these things yourself, and I have. So some of the ones I've been playing with are here, like for example these dates, and this one right here. Repeat the phrase "all cars eat gas 4 times." On the odd times, drop words that start with vowels. All right, so yeah, a little bit of a mindfuck, but let's say repeat the phrase "all cars eat gas 4 times." Okay. On the odd times, drop words that start with vowels. Okay. So all cars eat gas. All right. All cars eat gas. Repeat that 4 times. And on the odd times, drop words that start with vowels. And that is A and E. So on the odd times, which is going to be the first time and the third time. So the very first result for all cars eat gas 4 times should be cars gas. The next one should be all cars eat gas. Then again, cars gas, right? Because it's going to be removing all and eat on the odd times, which is going to be the first and the third. So in our chain of thought approach, and I will actually show you here, when we are going and using GPT-3, okay? And so GPT-3 will go down here to the actual repeat the phrase "all cars eat gas 4 times." Okay, so here's what it gave us: GPT 3.5 Turbo. Here's the repeated phrase as requested. On the odd times, drop words that start with vowels, and the response is wrong. All cars eat gas. Cars eat gas. All eat gas. Cars gas. It's complete trash. Not even just wrong. It's just complete trash. Like, it didn't even do that. It just eliminated the word. So as you can see, somehow in its mind, in the back there, through this rather simple, what we consider chain of thought, it's hard to tell that whether it's direct or chain of thought, but this is the chain of thought prompt. It gets it wrong. So you then try to do it. Actually, I'm sorry, that is the direct one. My bad. That is the direct one. That is basically the direct question. And then chain of thought is right here. Chain of thought is this one. Repeat all cars eat gas 4 times. And then it gives it the example. That is all cars eat gas, all cars eat gas, all cars eat gas. All right, that's the 4 times. On the odd times, I have to drop words that start with vowels. And then it gives them the wrong example, which is very, very fascinating. And because of that, the answer is still the same trash. It's the same trash. Isn't that fascinating? Where there's the direct, which doesn't confuse it, and it gives you trash. And then there's the chain of thought, which intentionally attempts to confuse, and it still comes up with the same exact garbage. And it thinks the first line includes the original phrase. The second line drops the first word all because it starts with the vowel. Why? Why would it do this? Why the second line when the request is obviously for, it should have been on the first. The third line drops the second and fourth words, cars and gas, because they start with vowels. Do you see what's happening? I mean, complete hallucinatory trash. This is what we call hallucinations. It's just complete like jumble at this point. The fourth line drops the word eat because it starts with a vowel. Sure, at this point, everything starts with a vowel. Pattern is repeated for all four instances of the phrase. So let's see what happens when we do the program aided one. Now with 3.5, it's going to probably give me a whole bunch of like, yeah, the code you provided, blah, blah, blah. But let's see if at the end of the... So if you were to call the solution function, it would return the string, all cars eat gas, all cars eat gas, which is the correct answer for the prompt. See, it's not correct here either. Interesting, huh? It doesn't always do it. So let's see. Now, in their example, it actually came back. It actually came back with the right result. And oftentimes, I've heard that there are potentials for different outputs for the same request. So in this case, it looks like it's doing the same. The code you provided is correct and would output the desired string as per the prompt. It defines the function called solution. It creates a list of words, all cars eat and gas, and then loops over the range of 1 to 5. And for each iteration, it checks if the iteration number is odd or even using the percent operator. Okay, that's correct, yeah. Then if the iteration number is even, it extends the listing list with the original list of words. That's not right, is that? It extends the resulting list with the original list of words. Otherwise, it loops over the words in temp and only appends those that do not start with the vowel to the resulting list. If it's even, it extends the resulting list with the original list of words. Otherwise, so it already gets confused. This already is iterations even. No, that's right. It goes on, and if it otherwise, that means it's odd. It should get rid of the ones that start with the vowel. Finally, joins the resulting list into a string with a space separator and returns that string. So if you were to call the solution, the function will return the string, all cars eat gas, cars eat gas, all gas cars. It's the same shit, right? Same trash as before. Cars, gas. Yeah, same trash. Let's try this now with 4.0. Okay. And with 4.0, we'll do... Let's see if it's just going to understand the direct. How's that, huh? How's that for an improvement? Really, really good. Really good. Let's see if it understands our code, which 3.5 did not. Let's see what it does to us here. So it gives us some kind of pseudo Python code, which will work. Okay, so it just basically formats the same exact thing that we just did. Dropping words that start with vowels on the odd times. Here's the function. It will return the modified repeated phrase as a single string. What's the string output? Cars, gas, all cars eat gas, cars, gas, all cars eat gas. I got it right. So I got it right. As you can see, 4.0 significantly better when it comes to all kinds of prompts and understanding even the program-aided one. Now, most of these program-aided ones were done with DaVinci, and you can see in the actual science paper that they released. So they say that, of course, the large language models have demonstrated impressive ability. Most of this is because of chain of thought. And then when they employ, excuse me, when they employ the program-aided one, significant improvements. You can see, so you can check out this paper. This is an awesome paper. Let me know if you'd like me to share. I'll actually probably share this into the description. Program-aided language models. So read this up. And if we go down, they have a lot of cool examples here, a lot of results. And if we go down to the very end and check out the final analysis. Taking forever, sorry guys. So in conclusion, new method of natural language repetition, natural language reasoning using programs as intermediate reasoning steps. Differently from existing language model-based reasoning approaches, the main idea is to offload solving and calculating to external Python interpreter instead of using the LLM for both understanding and the problem and solving. This results in the final answer that is guaranteed to be accurate given the correctly predicted programming steps. Okay, guaranteed is but we demonstrate the seamless and synergy between an LLM and a Python interpreter across 13 tasks from big bench hard and other benchmarks. All these benchmarks PAL outperforms larger LLMs such as PALM 540B, which use the popular chain of thought method and sets new state-of-the-art accuracy on all of them. We believe these results unlock existing directions for future neuro-symbolic AI reasoners. And neuro-symbolic AI reasoners, just so that nobody else is confused as I was, they represent a new paradigm in artificial intelligence that combines the strength of symbolic reasoning and neural networks. This approach aims to create more powerful and flexible AI systems that can handle complex and abstract problems. At the core, neurosymbolic AI reasoners use a combination of symbolic reasoning, which involves the manipulation of logical and rule-based representations of knowledge, and neural networks, which are trained on large datasets to recognize patterns and make predictions. So I asked a couple of more things where some of the examples of architecture that can efficiently process both symbolic and numeric data. And they give us a couple of things: neural symbolic integration, graph neural networks. That's a really fascinating one for me. Differentiable programming. This is actually, I think, similar to what we saw here with PAL. This approach involves incorporating symbolic reasoning into neural networks by representing program code as a differentiable function. This enables the network to learn both symbolic and numeric operations simultaneously, which can improve its ability to reason. Then there's the one that I was interested in the most, which was transformer-based models. This type of neural network that is designed to process sequential data, such as natural language, by incorporating symbolic representations of language, such as knowledge graphs and ontologies. So incorporating graphs and ontologies into the transformer architecture. And some expansion on that was that the key innovation of transformer-based models is the self-attention mechanism, which allows the network to weigh the importance of different parts of the input sequence when processing it. In some way, it creates one approach it says here is to use transformer-based models in multitasking. Multitask learning, the model is trained on multiple tasks simultaneously, with each task providing a different type of input. For example, one task could be to predict the next word in a sentence, while another task could be to classify the sentiment of a sentence. And so you can have, and there's another approach here, they said you can have basically knowledge distillation involves training a smaller, more efficient model, as they call the student, to mimic the behavior of a larger, more complex teacher model. And the teacher basically tells the incorporates symbolic representation of language, while the student model is trained to emulate its behavior, and they communicate, that goes back and forth. and improve and optimize each other. So I started to come up with a flow chart to incorporate symbolic representations into transformer-based models using multitask learning. We define the tasks, pre-process the data for each task, initialize the transformer model, define the loss function, train the model on all the tasks simultaneously, evaluate the performance of the model on each task, and if it's unsatisfactory, adjust and repeat. And so we can play around and continue moving through this, and I'll talk more about this in some additional videos where we talk more about how we can use this in testing neural networks and testing these large language models by incorporating this approach along with some adversarial prompting to start to really kind of see if we can get to the core of some of these language models and see if we can manipulate them in some way. So hope that you found this interesting. Like, subscribe, and leave a comment. I would really appreciate that. That would, I think, help the algorithm find my videos a bit more. So thanks, guys. Thanks for your attention, and I hope you enjoy it. Bye.